Assalamu alaikum. Myself SN Siddiq and my registration number is 23TE3. Today I'm here for the presentation on the topic that is basically implementation of BFS and DFS in through Python. Before implementing the BFS and DFS, let us see that what actually BFS and DFS is. BFS is basically breadth first search, and it is a type of a graph traversal algorithm that explores nodes level by level, starting from a source node or a root node. It first visits all the neighbor of the starting node before moving to the next level of the nodes. BFS uses a QE, first in, first out data structure to keep the track of the nodes to visit the next node. Okay, so basically BFS is a type of traversing algorithm in which we go level by level. Okay, so how we create level is like we see the root node as our level one, and then all of its parent, all of its child are basically level two, and then their childs are level three, and then their childs are level four, and so on up to the termination node. Termination node is basically the node that is at the end. This is a binary tree basically. So BFS is a type of searching traversal algorithm in which we go level by level. So when we will apply the BFS in this algorithm, in this binary tree, so what we will do that we will write A first, then B, C, D, then E, F, G, H, and then I, J. Okay, so this is how level by level we will go in traversing. Okay, this is basically BFS. Now, if we see what is DFS is, DFS is basically depth first search, and it is another type of graph traversing algorithm that explores as deep as possible in one branch before backtracking. So basically, DFS is opposite to BFS in a sense that it does not go level by level. It moves on the left side first, like it goes or explores the one side first, and then it moves to the other side. If we apply the DFS in this binary tree, so it will move in a sense like it will move from A to B, then to E. Now it will move to B's right child, that is F, and then it will move to C, and then it will explore all the left sides of C. As we can see here, there is no left side of C, so it will only go to the right side, that is G. Then it will go back to the D, and then we'll explore all the left side. So DFS is basically a type of algorithm, traversing algorithm, in which it explores one side deeply and then moves to the right side. Whereas in BFS, what we do actually is we do level by level. So if we see the results of BFS and DFS, so we can see that BFS is simply level by level A, B, C, D, E, F, G, H, I, J. But DFS will be like exploring the left side first and then moving to the right side. So it will be A, B, E, then it will move to the B's right child, that is E, then it will move to this right child of B, that was F, and then it moving F's child, that was I, then moving to the C, then G. G has no child, it will move to D, and then D, H, and J. So this is how DFS is working. BFS is level by level, and the DFS is basically exploring one side completely, then moving to the next side. Now, if we talk about what is the need of these two types of searching algorithm, so we see that graphs appear everywhere in computing, like internet networks, social networks, road maps, AI search problems. So BFS and DFS helps us to traverse the graphs efficiently, search for the nodes that we want, find the relationship between the nodes, and solve path finding problems. Okay, so this was the required, and this was the need of these two types of searches. Now if we talk about the complexity of these two traverse algorithm, then that it will be O into V plus E. The complexity is basically divided into two parameters. Okay, the complexity of space and the complexity of time. Complexity of space is that how much space will be required by your task in order to run on a specific system, and the complexity of time, that how much time it will take to reach the end, or it will show you the results of the whole scenario it has discussed, or whole the scene it has captured. Okay, so this is basically O into V plus E, and V is representing the nodes that it is covering. I have created three scenarios in which we have total 10 nodes in each case. Okay, and the edges are basically the arrows that are basically connecting the two nodes. As you can see here, this is basically the word edges that we are referring to. And if we talk about the applications of both BFS and DFS, so applications of BFS include shortest path in unweighted graphs, web crawling by search engines, GPS navigation systems, social network, friend suggestions, and broadcasting in networks. Whereas if we see the applications of DFS, it is topological sorting, cyclic detection in graphs, maze solving, artificial intelligence, search problems, finding strongly connected components. Now, let us move to the main part of our task, that was basically working on implementation of BFS and DFS. So if we see the code, I have written down the code here. It is like from collections import DQE. Collection is basically a Python module, and DQE is that I told you earlier that it is a double-ended queue, and we are implementing this QE because BFS is a FIFO type, or FIFO uses data structure, FIFO type data structure, and DFS uses a stack type, a LIFO data structure. Here we are defining the function of BFS, and then the next line is basically will keep the track of the nodes that we will cover throughout the traversing. The next is that we are creating a QE. In the next line, we are basically adding that specific node that we will visit. Now, order is equals to and is creating an empty array. This array is initially empty. As soon as we will visit or we will traverse the nodes, we will put these nodes or those nodes into that specific array that is named as order. Now we are applying a while loop, and then we are seeing that, as I told you, that BFS works as a FIFO type data structure. So what if we wanted to remove a node from our full array? So what we will do? We will simply write this line, and it will remove the first element of the node. Like if, for example, if the array is A, B, C. Okay, so if you want to remove an element, so first element will be removed because the BFS is following a FIFO data structure that says like first in, first out. Okay, the next is that if you want to append any node, we can append that into using this command into our empty array. And the next is that covering the neighbors of the graph node. If we see here, this is A, that is root node, and B, C, D is its neighbors. Okay, so when we traverse, we need to see that it is covering both of its parent neighbors. So if the neighbors are not visited, they will visit it, and then it will add that into the order QE. Okay, and then return the order will actually return the BFS final answer after all the traversing. The next is implementation of DFS using a def function, and it is visited is equals to set will do the same task as in BFS. Like it will keep the track of the nodes that will be visited. It will create a stack because DFS follows a stack type data structure. And then we are creating a while loop in which we are writing. And if you want to remove any node, how we can do that? Okay, so for example, if the structure, or if the array is containing A, B, and C. And as we know that a stack removes the element that is inserted at the last. So, okay, so the after deleting a node, the resulting will be from ABC to AB only. The next is that it will also see for the neighbors that are being visited of the specific node, and if the that specific node is not being added, so it will do that. And then at the end we will print out our last result, or the array that is being done with the DFS type of searching algorithm. Okay. Now the next is basically the three scenarios that was required by Dr. Jamil, and they have given all these scenarios containing 10 nodes so that I can explain it more better. So these are three scenarios, and we have given the name to each scenario, that is social network graph, city roadmap, and then third is computer network. We can give any name to them. Basically, let me show you the graph of the binary graph of the first scenario, that is this one. Okay, so BFS will be A, B, C, D, E, F, G, H, and I, J, and the DFS will explore the left side first, and then so on the other side. As we can see here, now in this determining, we are using A. This A, these all uh, letters or these all alphabets that are written on the left side are representing the reference node, and these all are representing all the nodes that are connected to those reference. Like if A is being as a reference, then BCD was connected to A, as we can see in the binary tree. Similarly, if we talk about B as a reference, then A, E, F are connected to it, and so on. And this is basically it will print the answers of BFS and DFS, like calling of the function, performing the task, and then displaying the result. And similarly, again here in the graph 2 or in the scenario 2, on the left side we are having reference points or reference nodes, and on the other side is the nodes that are connected to those reference nodes, and then there is displaying of it, and then third task is the same thing as I told you earlier. Now if we run this, what we will see as an output is this thing. You can see here the first scenario is called as social network, and then we have displayed the results after the BFS and DFS traversal that were also shown on the Word file, and these are our answers. In the scenario 2, you can see here that in BFS we have covered level by level, but in DFS we have covered one left side first and then moving to the right side, and then in the same type of way in the whole process. So this was our basically implementation of BFS and DFS through our Python code. That is all from my side. Thank you so much.